Hello and welcome to week 5 in Statistics for Psychology. And we're looking at some pretty core information here. And now this is the discussion of the normal curve, or the bell-shaped curve as we often call it because of its bell shape. Now it's important to understand that almost all of statistics, and as it relates to probability and significance, relates to this particular chart. Now, in order to understand the construction of the standard curve, you have to understand how we actually erase that. In order to understand the utility, we have to know how we construct this particular graph and representation of data. I want you to think about the frequency charts that you've been doing. Frequency charts say how many of a particular value did you get, and you created bar charts. Now, if you gather a lot of information on you're going to have a lot of bars. And eventually, that you get so refined in your data that the tops of those bars can be actually outlined as a curve. And the information will go like this, or whatever shape that information is. And that curve, the bell-shaped curve, represents a frequency distribution. So you have the scores along the bottom and the number of those scores along the top. So when there's things that don't occur very often, it's a little bar. And when things occur a lot, there's a big bar. And there's minutia to the point that you can draw this curved line around it. The construction of the bell-shaped curve, or the normal curve, has to do with the central limit theorem. A theorem is a mathematical principle that has been proven mathematically and is assumed to happen true in the world. So let's say I'm measuring something like intelligence, and there's all the people in the world that I've measured their intelligence on. Now, when I'm doing a study on intelligence, I pick a sample. And I take that sample of people, and I get the average intelligence score of that sample. And let's say I do it again. I get a sample, and I get their average. And then I get another sample, and their average, and a sample, their average, and a sample, their average, and all that. And I take all those averages, and I create a frequency distribution of sample means. I'm not doing a frequency distribution of the individual scores. I'm doing a frequency distribution of the means of samples. The theorem poses that if you do that, theoretically, the distribution of sample means is going to approach the normal curve. So, given a set of data, given a set of people, if I sample, there's a greater likelihood that my sample is going to appear in the middle. Those middle scores happen more often. If I do another sample and the sample's very high, that's unusual because it's very unlikely for me to get that kind of sample. Same if it's very low. So the curve represents the likelihood of your sample mean happening purely by chance. So by chance, it's very likely that your sample is going to be in the middle. It's very unlikely that your sample is going to be over on the side. That sense of likelihood of something is the key utility for the use of the standard curve. So if I'm doing an experiment and I want to see if my intervention has had an effect on intelligence, and I sample my group and they score off the charts over here, there's two things I can say. First, if I'm just sampling regularly, getting a sample with that particular score as their mean is very unlikely. Therefore, it must be that way because of my intervention. I must have made this group unique compared to average people by that intervention. those lines in the sand, where we say, oh, this is different enough, are based on the distribution of sample means inside the normal curve, bell-shaped curve, normal distribution. When we develop a standardized test, like the SAT, or standard measures like mental health measures and stuff that have been gone through the process of standardizing, what we have done is we've conducted enough samples with that particular test to create our own bell-shaped curve. So when you use a standard test, you have this great ability to be able to look at the scores you got and compare them to the likelihood of people getting those scores across the nation. So when we take the SAT, it's been standardized, and we can get information about how we are doing compared to other people that have taken the test. And that's the utility of that. One of the first tests that we're going to learn in this class is z-tests, where we take our scores and we convert them in a way that tells us how they relate to that standard curve, depending on the test that we're using. If we're using a test that has been, quote, standardized, there's actually an official process for going through that. So the first discussion is actually for you to talk about standardized tests. And they're good and they're bad. They tell us the useful information, but they're just a picture. And I just want you to be able to have that discussion. The quiz, first off, asks you to explain the central limit theorem. There's a definition in the course book. There's the definition that I have. If you look it up on YouTube, people will explain that. Central limit theorem is explained on the crash course. You can look up whatever it takes for you to get your head wrapped around that idea about central limit theorem being the idea that the distribution of sample means will approach the standard curve. You've got question one. Then what I have you do is I have you look at some scores and compare them to a standard score on intelligence, a standard curve on there, and say things about those scores. What can we say about those scores, those individual scores, because we know the distribution of sample means. We have a standard curve for that particular score. So some concepts to get your head wrapped around here is the standard curve, central limit theorem, and the ability for us to look at individual scores and determine how well those individuals or how poorly those individuals did compared to the other people that have taken that test. So again, we're still a little bit in descriptive statistics. There is a predictive component of being able to use the standard curve when we have a standardized test, but we're not there yet. So that's the chapter for this week. Chapter 4, the normal curve, the standard curve, the distribution of sample means. They're all the same thing, the bell-shaped curve, that thing. And we will be repeatedly using that concept for probably the rest of the class. So key to get your head wrapped around both the construction and the utility of the normal curve. So be well, and I will see you next time.